Is this the cheapest mill on the internet? Maybe. This is my milling machine. Let me give you a show and tell. The reason why it's so cheap, it's because this steel is all structural I-beams that I've managed to just collect up over the years from various building projects, not my building projects, just people selling them on the internet. And I've just welded it together fairly badly with my stick welder, and I've kind of been building it up over the years. So the reason why it's this shape, it's because it was supposed to be a CNC lathe and mill combo. So this XY table was going to hold a lathe tool post, and it's going to have a big chuck here, which it still might, but I've kind of changed my mind slightly on that. This is actually just off of eBay, and since buying it, I've converted this table to ball screws and put these engineered these end plates with a with the NEMA 23 belt drive and some reduction here. So that's fairly sort of traditional, I suppose. Apart from the fact that it's kind of rotated 90 degrees, so the long travel is forward and back, and the short travel is side to side. I don't know why I did it like this. I think it was just for the frame size to make sense. And then the Z-axis was a cheap I keep saying cheap, it is. It is all scrap steel plate that I got from someone taking down an agricultural building. So it's like 10mm thick plate, angle iron. This angle iron is actually two pieces that sit inside each other. So you see, this is the inside part, that's the outside part, and that is, as far as I can tell, the most kind of rigid and cheap ass way of achieving a Z-axis. The point of doing it this way was that it's kind of a minimal viable project, right? So when it's actually up and running and the geometry is like fairly sorted, it can mill its own improvements. So my plan is to have linear rails for all three axes, but you know, proper good ones, not the cheap ones. Because the reason I went for this is because there's literally zero play, and you can put like a huge amount of thrust load on it, and there's no deflection whatsoever. Whereas linear rails, I mean, I don't know, you know, industrial ones obviously are amazing, but the cheaper ones, I was going to put some grease ports in here and just inject the grease at a very high pressure and do it that way. This is again sort of life-threatening janky shit that I've just done over the years. Don't judge me, this is terrible, I know. Vargo blocks, cheap Chinese Vargos. This is a little Intel PC board, parallel port, obviously old school, stepper drivers. I think this is a 36 volt system, apart from the Z-axis, which is a full 240 stepper. Got a VFD in here, obviously the cheap Chinese Huang something driver, which was for a big motor that was supposed to be mounted sort of here with the belt drive, but that kind of, I abandoned that just because of doing two things that are poor at both things is not as good as one thing that's half okay at its job. And I have a mini lathe now anyway, so anyway, this might get restarted at some point. This spindle is a Chinese AliExpress special. These BT30 spindles are really common. I actually had the seller stick a pulley on here for me. I sent them the drawings for the V-belt multi-V pattern. It's not like amazing, but you know, it's again a minimum viable product as far as I'm concerned. It's got a little short multi V belt here, and this is a motor from a treadmill. It's about a 2500 watt motor, I think. So it's 2.5 kilowatts. Brushed DC. It's controlled by a driver in here. It's a little DC motor driver. It's actually really nice. I can actually power this up for you. The display doesn't work, but it's got, you know, a huge amount of torque actually. I can stop it with my hand at this RPM, but at a decent RPM I probably shouldn't touch this. Yeah, I can't stop that. It's I guess, and it's reversible obviously. It actually sort of tries to keep speed, you know, without any sort of feedback. This isn't, you know, a servo motor or a stepper. It's just a simple BLDC. No, brushed DC. Brushed? I don't know. There's no cogging. Maybe it's not even a permanent magnet. Can't remember. I did a load of research on this. This is started building this thing like years ago, when I didn't really know as much about stuff as I do now, and I was dumb and young and full of energy. I have a bit less energy, a bit less money now, but I'm slightly wiser. BT30 spindle, standard bearings, BT30 tooling, manual drawbar, this janky thing. I need to make a proper clamp for it. Ball screw, again, Chinese crap, standard stuff. Gas spring here, helping sort of pull it up. It wasn't very easy to have a counterweight because of the shape of the machine. It doesn't have a column, so it would have just been sort of like back there. So I just did a gas spring. I worked out the rate, the force and everything, and yeah, roughly works great. I mean, no complaints. My only complaint is the amount of backlash actually in the Z-axis. So I don't know if you can see this much. It doesn't even move. So that is just due to the friction that is in these ways, and the little single ball nut here is just not capable of overcoming so much static friction. So yeah, I'm gonna get like a double thing, ball nut, see how that goes. For the moment I just got it backlash compensated in Mach 3, so it's alright. That's the Z-axis. Again, AC stepper there, which again I got cheap off of eBay. There's some kind of factory closing down sale. The guys had loads of them, so I bought a few. And standard cheap AliExpress vice, cheap XY table. It's the one usually with the manual pulleys, but I've taken the lead screws and made it ball screws. And PC is in there. I've got a little screen and a little shelf here. Swivels. A mount here. So I've got the mouse here. Nice. Got this bench out of 80 by 80 square tube, 50 by 50 mixed together with some gussets. Got some big old wheel bearings there for the wheels. Literally just the bearing. It's working amazingly well. And this side is it's got a little locating pin, so it pops into the jack there, so I can jack up this side of the table and move the whole thing, which is great. This machine frame, I could say, already weighed a ridiculous amount, a couple of 100 kilos I think, just for the steel. And I then filled it with sand, so it's completely filled up with sand. I think it's probably about 130 or 140 kilograms of sand in here. It was about 7 bags, 7 UK size bags. So anyway, all through here, this column's full. It's totally dead. It used to ring like a church bell, now it's dead, which is great. I cut these plasma cut these holes, so this platform here has a large flat area, so the big kind of porthole cut through there with the plasma, and chucked the sand in there and then sort of vibrated it again here as well. vibrated it with my pneumatic scaler. So it is as good as it's ever going to get. I worked out the price for epoxy resin, composite granite, whatever you call it, epoxy granite, and it would have cost about £400 to do the volume of granite needed for the channels here, and sand was about 30 quid. So literally a tenth of the price. I'd probably bet it's not quite 10 times. Epoxy is not 10 times better, definitely. I don't need any strength. This thing is strong as hell. It's just for the damping of the vibrations, which actually became a problem where, I mean, I don't know where the main problems are. There's lots of problems with this machine so far, but it's just destroys end mills. This was actually trying to cut tool steel. It's either tool steel or 4140. I don't know what this BT30. So I modified this into a fly cutter. Yeah, the geometry's bad. I didn't know what I was doing, but this slot was milled with that end mill. As you can see, it's proper foobarred, chipped and all sorts. And yeah, so I mean, it did this already with not as much reinforcement as it has now. It actually had a slightly more simple shape, and I just added these I-beams to strengthen it in various directions. Not that it needed strength, I was just trying to kind of create these hollow channels to fill with the aggregate. So yeah, and that is how it is now. I'm going to make a little series about doing things to this. So yeah, feel free to subscribe and stick around and get notifications and whatnot. I hope it's going to be entertaining. As I said, this is like the cheapest thing I've ever seen online. CNC thing I've seen online. I mean, there's lots of, you know, people making mills now because of the part supply. Linear rails and ball screws and stuff are fairly easy to get hold of, fairly decent quality now, but like that's still too expensive for me. And this was built literally on like a wooden bench with not much, you know, lots of measurement error and stuff, and just like a basic square. And yeah, it would just be good to see what kind of things I can get out of it, what kind of surface finish and whatnot. So yeah, I mean, if I was to cost the whole thing up, oh god, jeez, I mean, right, frame, not more than 100 quid in metal. I got these beams, you know, from people on Facebook Marketplace. I've turned up to their houses, I've cut them up and put them in my car and stuff, and yeah, literally it's just been like that. This angle line actually I bought just for the plain reason that, you know, I needed it as straight and true as possible. The rest is just scrap. I mean, yeah, like the BT30 head was 150 maybe plus shipping. This treadmill motor was probably like 30-40 quid or something. The driver was maybe like $80 or something. This box cost some, but yeah, I've 3D printed a bunch of stuff. Obviously the brackets are homemade. This was only like 100 something. The XY table, then the ball screws, and a lot of engineering to like get these all lined up and get the belts the right tension and all that sort of stuff. But yeah, I mean, that's all free, isn't it? Free time. This massive plate actually was just some guy had a little workshop on a farm, was selling locally, so I picked up a couple of these massive plates. I mean, I can barely lift them, so picked up is a strong term, but like, yeah, I mean, just as like a reference surface for everything to sit on. This enclosure, this bill, yeah, belonged to some other. I mean, this is so old, it's got like weird Whitworth, made in Great Britain, Whitworth thread or something. I mean, it's not, yeah, it's not even metric. Shoved everything there. The VFD was cheap. This panel, I/O panel, actually 3D printed with various pass-through connectors. So this was going to be, I've got another box with loads of buttons and presets for the VFD for the lathe control. So this multi-pin actually breaks out into those. But yeah, that's for another video. Got a braking resistor in here and everything. Little PC power supply, little micro, what do you call it? Ultra small form factor, whatever. I think this was used off of eBay. This is 1.6 gigahertz, like built-in Celeron or something. No, Atom board. The SSD was new. Small, tiny SSD. I think for how little money it's cost, it's like incredibly sturdy. I think it's a level above the simple kind of column machines that people make out of scrap metal, just because of the extra frame strength and size. I think it's, once I upgrade the spindle to something more decent, I think it can mill, it's going to be able to mill quite a lot of strong materials. But yeah, we're going to see. So anyway, stick around and see how I get on.